Welcome to the Marston Science Library Guide to Arduinos. Today, we will be working on the Piezo tone tutorial. Our goals: learn how to translate from notes to frequency in hertz, learn to translate simple sheet music to letters and durations, learn how to include other files in your sketch, and learn how to use the tone function to create simple melodies out of Piezo. Let's get started. In this step, we will learn how to translate from notes to frequency in hertz. The basic formula for the frequencies of the notes of the equal tempered scale is given by f sub n equals f sub 0 times a to the nth power, where f sub 0 equals the frequency of one fixed note which must be defined, where n equals the number of half steps away from the fixed note you are, where f sub n equals the frequency of the note n half steps away, and a equals 2 to the 1/12th power. The 12th root of 2 equals the number which, when multiplied by itself 12 times, equals 2. A common choice when translating notes to frequency is setting the A above middle C, or A4, at f sub 0 equals 440 Hz. Using a scientific calculator, you have A equals 2 to the 1/12th power, which can be calculated using the x root y function. N is the number of notes away from A4, higher note positive, lower note negative, so a to the n power can use the x to the y power function, and f sub 0 we will keep constant at 440 Hz. For n, you have to include white and black keys. Knowing that there are 12 steps per octave and A4 equals 440, what should A3 equal? Keep in mind that if you are at a higher note, n is positive. If you are on a lower note, n is negative. If f sub 0 equals 440 times 2 to the 1/12th power times n is negative 12, we have 2 to the negative first power times 440. So we have 440 times 1/2 equals 220 Hz. So A3 would equal 220 Hz. What about for A5? If we know that A5 is 12 steps away in the octave, we again know that the higher note n is positive. So 440 times 2 to the 1/12th power to the 12th power equals 2 times 440 equals 880 Hz. So A5 would equal 880 Hz. Now that you know how to calculate frequency, you want to make sure that you use numbers the Arduino can use and round to the nearest whole number. Luckily, Arduino has created a library of all of the frequencies needed. We will use this as our pitches.h library in our Arduino code. To include libraries in your sketch, use #include. Library files use the .h file type for the headers of library folders. Navigate to the drop-down arrow and add a new tab in your sketch in the Arduino Integrated Design environment. Name it pitches.h and hit OK. User-generated libraries like pitches.h will go in the subdirectory with your sketch. We're now going to paste the code we found before of all of the note frequencies. I will select all and copy, and I will paste it here to our code. In this step, we will learn how to translate simple sheet music into notes and durations. We are reading to find which note we need on a scale of C1 to C8, including sharps and the duration of the note. For note type 1/16, our duration for the Arduino will be 16. For 1/4, it will be 4. For 1/2, it will be 2, and for 1, it will be 1. In order to read sheet music, we must be able to read the notes. On the treble clef, we can see the range goes from C4 to G5. C4 is on the line below the bottommost line of the 5 lines of our treble clef. We have E4, G4, B4, D5, and F5 as our 5 lines. Our spaces include F4, A4, C5, and E5. In terms of note duration, the most commonly encountered note durations include the whole note, the half note, the quarter note, the eighth note, and the 16th note. The whole note is an open dot, the half note is an open dot with a stem, the quarter note is a closed dot with a stem, the eighth note is a closed dot with a stem and a flag, and the 16th note is a closed dot with a stem and 2 flags. In your code, be sure to first include your pitches.h library. # include, quote, pitches.h, end quote. Then declare your variables for your integer sensor reading to equal 0. Next, create and declare an integer array of your notes using the names referenced in pitches.h. Use empty straight brackets after an array name to indicate that data is to be added but note size is given, and curly brackets to fill in your data. Your for loop will access your arrays. Repeat step 3 by creating an array of your tempo or note durations. In your void loop, use a for statement. There are 3 parts to the for loop header. For, and then in the parentheses, your initialization, your condition, and your increment. For initialization, declare an integer for the first note in your melody. For condition, count how many notes are in your melody array and have integer less than that number. For increment, use the compound operator ++ to increment from 0 to your last note. This for loop plays the notes in succession. In order to determine how long each note should be played, declare an integer to store the duration of the note. Use the assignment operator equals to set this integer equals to the length of a whole note. I used 1200, but you can use 1000 milliseconds, divided by your second array crossed with your first array. So we have note durations multiplied by our array this note. This aligns the order of the notes with the order of durations. Next, use the tone function. There are 3 parts to the tone function. Tone, and then in parentheses, your pin number, your frequency, and your duration. First, set your pin to digital 8 where Piezo 2 is connected. Second, set the frequency to your first array melody by the declared incremented this note. Third, set your duration to your newly declared integer note duration. Next, declare an integer for a delay between notes and set it equal to the note duration multiplied by 1.3. Use the delay function to set the time of delay between notes in milliseconds. Use the noTone function to stop the tone from playing at the end, since it is in the void loop function. Check all semicolons and brackets. In order to run your code, you must first save the file, File, Save. You will then click the check mark to verify your code. If there are no errors in your code, the sketch will compile using the loading bar until it is done compiling. You can then plug in your Arduino into your computer using the USB cable. You will then want to go to Tools. You will want to make sure that Board is selected at Arduino Uno and Serial Port has a connection. Mine is USB modem 411. Yours may be something different. You will hit the right arrow upload and watch it upload to your Arduino. In order to make the piezo tone, you will need to plug in the piezo with the red pin to digital pin 8 and the black wire to ground. You will then need to upload your code to the board.